Lev Landau was born on January 22, 1908, in Baku, Azerbaijan, which was part of the Russian Empire at the time. From a young age, Landau showed a remarkable talent for mathematics and science. He was the son of a Jewish family, and his parents encouraged his education. His mother, a teacher, and his father, a doctor, understood the importance of learning and supported their son's interests. At the age of 13, Landau entered the University of Baku, where he started his education in physics. His extraordinary ability to understand complex ideas led him to quickly stand out among his peers. After completing his studies in Baku, Landau moved to the University of Leningrad, which was famous for its high level of scientific research. At Leningrad, he worked under the guidance of prominent physicists and developed a passion for theoretical physics. He showed great interest in quantum mechanics, a branch of physics that describes how very small particles behave. Quantum mechanics is very different from the physics of everyday objects, and often involves strange phenomena that are difficult to explain. Landau's ability to understand the difficult and abstract concepts of quantum mechanics was already evident at a young age. At the age of 22, he published his first scientific paper, and by the time he was 30, he had already become a leader in the field of theoretical physics. One of Landau's most significant contributions was to the study of condensed matter physics. Condensed matter physics is the branch of physics that deals with the properties of solid and liquid matter. Landau's work in this area helped explain how materials behave at different temperatures and pressures, such as how they can become magnets or insulators. He developed a theory that described how different substances become superconductors, which are materials that can conduct electricity without resistance at low temperatures. Superconductivity was an exciting new field of research at the time, and Landau's ideas helped scientists understand how and why certain materials could behave in this way. He was one of the first to realize that the electrical resistance in some materials could disappear completely if they were cooled to very low temperatures. This discovery had important applications in technology, such as the creation of super-efficient power cables, and the development of powerful magnets used in medical equipment like MRIs. Landau also made contributions to the understanding of quantum mechanics, hydrodynamics, and the theory of phase transitions. Phase transitions describe how materials change from one state to another, such as when water turns into ice. Landau's theory of phase transitions helped explain how materials undergo dramatic changes in their properties when they are subjected to different temperatures or pressures. This work was very important in understanding not just materials in nature, but also how things behave under extreme conditions, such as in outer space. In addition to his work on phase transitions, Landau was known for his ability to explain complex scientific ideas in a simple and clear way. He believed that anyone with a strong enough desire to learn could understand the mysteries of nature, and he worked hard to make difficult topics accessible to others. In the 1940s, Landau published a series of lectures that later became known as Landau and Lifshitz. These lectures were later collected into a series of books that would become essential reading for students and scientists in the field of physics. Each book in the Landau and Lifshitz series covered a different area of physics, from mechanics to electrodynamics, and became a standard reference for generations of physicists. Landau's approach to teaching was revolutionary. He believed in the importance of deep understanding over rote memorization. His students were taught to think critically and to focus on understanding the fundamental principles of physics. Landau also made important contributions to the development of modern mathematical techniques used in physics. These techniques help simplify the process of solving complex equations that describe the behavior of physical systems. One of Landau's most significant intellectual achievements was his work on the theory of hydrodynamics. Hydrodynamics is the study of the behavior of fluids, such as liquids and gases. Landau's research helped explain how fluids behave under different conditions, which is important for understanding everything from weather patterns to the movement of air and water. In the 1950s, Landau worked on developing a mathematical description of turbulence, which is the chaotic movement of fluids that scientists find very difficult to understand. Landau's ideas about turbulence were groundbreaking, and they had a profound effect on the way scientists study fluid dynamics today. Another important achievement of Landau's was his work on the theory of superfluidity. Superfluidity is a phase of matter in which a substance flows without any resistance, much like a perfect liquid. Landau's theories helped explain how superfluidity occurs in certain liquids at extremely low temperatures. This discovery led to new ways of understanding the properties of liquid helium and other substances that behave like superfluids. In 1962, Landau was awarded the Nobel Prize in Physics for his contributions to the development of theoretical physics. The Nobel Prize is one of the highest honors a scientist can receive, and it was a recognition of his incredible contributions to science. Landau's work had a lasting impact on many different areas of physics, and his ideas continue to be used today in research on quantum mechanics, condensed matter physics, and other fields. Despite his many achievements, Landau remained a humble and focused individual. He did not seek fame or personal glory, but instead dedicated his life to solving the mysteries of the universe. Landau spent much of his career working at the Institute for Physical Problems in Moscow, where he continued to make groundbreaking discoveries. In addition to his work as a physicist, Landau was also a mentor to many students. He took great pride in teaching and guiding the next generation of physicists. Landau was known for his strong belief in the importance of intellectual independence and encouraged his students to think for themselves. Many of his students went on to become famous physicists in their own right, including Andrei Sakharov, who later became known for his work in nuclear physics and human rights. Landau's influence on the field of physics is still felt today, as many of his theories continue to shape scientific research. He is remembered for his ability to make complex ideas understandable, and for his dedication to advancing the understanding of the natural world. Throughout his life, Landau was dedicated to solving the mysteries of the universe, believing that science could improve society and lead to a better world. He was a passionate advocate for the power of knowledge and the importance of scientific discovery. His work continues to inspire new generations of scientists and physicists to explore the world around them. Landau's curiosity and passion for science never faded, even as he got older. He continued to work on new problems and ideas until his untimely death in 1968. He passed away at the age of 60, but his legacy lives on through his contributions to the field of physics. Lev Landau's story is one of perseverance, intellectual curiosity, and dedication to the pursuit of knowledge. He will always be remembered as one of the greatest physicists of the 20th century, a pioneer whose ideas continue to shape the scientific world today. His work laid the foundation for many of the technologies we use today, including MRI machines, particle accelerators, and the study of materials in extreme conditions. Landau's influence on modern science cannot be overstated, and his contributions will continue to guide physicists for generations to come. Through his work and his mentorship, Lev Landau changed the world of physics and made an indelible mark on the history of science. He will always be remembered as a scientist who pushed the boundaries of knowledge, inspired others, and sought to understand the mysteries of the universe.